Hey everyone, this is Steve Bishop from ProgrammingMadeEasy.com and of course Gartman Technical Services. So about a month ago I released a video about interfaces and implementing them in your Access database, and I included something about inheritance in there too and polymorphism, stuff like that. And I got a pretty good response to that video, but I got repeated requests to see a bit more of a kind of a live demonstration or something in a more practical example of how to use an interface. So that's what this video is for. So you guys can see an actual real world example of how you would use an implementation of an interface. So I hope you guys enjoy, and thank you so much for watching. So for this example, what we're going to do is first create a new form, and this form is going to take two inputs. Okay, so it's first going to be a make of a vehicle, and the second thing is going to be the year of a vehicle. Actually, we want to do year. There we go, with a capital Y. So I'm going to make this make text box a little bit wider, and I'm going to move the year over a little bit, and I'm going to add my submit button here so the user can submit their entry. And the other thing I'd like to do is add a label here that's going to tell them whether or not their submission was successful or it failed. So since that's what this is going to do, let's set the font color to red and the size to 16. Let's just see if that looks good. Yeah, it does. Okay. Now nothing's really going to be in this label except for a space for right now. And we'll just move things around a little bit to make it nicer spacing there. Alright, so now the user is going to enter in a make and a year, and they click on the submit button, and what we're going to want to do is we're going to validate their submission. We're going to want to check to see if it's a model of vehicle and a year of that vehicle that we're willing to accept. So let's say like we're running a dealership or something, and we want to allow the user to check and see whether or not this is a valid entry. This is just a demo example, something that you probably won't actually be doing in the real world, because I don't know too many dealerships that are going to be doing this. Maybe they would. Maybe you would have an Access database that does this. But regardless, this is kind of a much closer to real world example, so I thought I'd give it to you guys. Now, I need to give these objects, these controls, some names. And I'm going to use Hungarian notation, and I know a lot of you guys might scream at me for doing that because you prefer that I do something like this, message label, right, or something like that. But I've just gotten real used to LBL message, and we're going to do this one as txt make, and this one is going to be txt year, and the submit button, we're going to do btn submit. And I really only do that for my controls. I only use Hungarian notation for my controls anymore, just because it makes it easier for lookup purposes as I'm typing out the VBA code. But my variables and stuff, I don't do the Hungarian notation. Just kind of my own personal preference. Now, let's go ahead and save this form. I'm going to call it the car entry form. Okay, so we're good there. Now, to do this validation, to make sure that the make that the user enters and the year that they've submitted is proper and one that we're willing to accept, in a procedural manner, it's a non-object oriented manner, we might do something like this. We're going to go to the onClick event for the submit button, and we're going to say, yes, there's my rubber duck splash screen. And we're going to say if me.txt make equals Mazda, for example, then, and if, now we're going to check to see the year. So if me.txt year equals or is greater than, let's say 98, then, and if, okay? And if it's greater than 98, then that means that it's newer than 1998, and we're willing to accept that, for example. So we'll do me.lbl message caption equals valid submission. Okay. Now, if it's older than that, we'll do an else statement, me.lbl message caption the car is too old. Okay, so you might do something like that. Okay. Now, this is pretty basic, pretty simple, but there's a few things that might trip us up here in this logic. First of all, what if the user puts in 1979? Well, 1979 is actually greater than 98, right? Because 1979 is bigger than 98. So we need to check to see how many digits did the user enter in for a year. So we're going to do this. We're going to do if me.txt year. We're going to check the length of the year. So we'll do length. But more specifically, we're going to convert the text box value to a string and then compare the year. Okay, so we're going to check to see if it's 2. Then, if it is 2, if the user entered in 2 digits, then we can go ahead and do all this stuff. Okay. Now, what if the user enters in one of those 4-year digits? So we'll do this. We'll do else, and we're just going to copy all this logic here and paste it there, and we're going to change the 2 to a 4. And then we're going to change the 1998, or the 98 to 1998. There we go. Now, what if the user doesn't enter in either 2 or 4 digits? Maybe they put in 1 or they put in 28. Well, everything else outside of a 2 and 4 digit year we're probably not going to accept. So we'll just say me.lbl message caption invalid year. Okay. Okay, so that solves that problem. But what if they put in 2 letters? And it's not even 2 numbers. Well, we're going to do another if statement. Okay, if me.txt year, we're going to check to see if it's a number. So we're going to use the isNumeric function to check to see if it's even a year. If it is, then we can go ahead and do all of this logic. So we'll tab that over, make it nicely indented, and if, but we also want to do an else statement here, so that if it's not a number, then we're just going to do this again. We're going to say invalid year. Okay. All right. So we're checking to see if it's a Mazda. Then we're checking to see if the year that they've entered is even a number. Then we're going to check to see if it's a 2-digit year, then compare it against 98. If it's a 4-digit year, compare it against 1998. And if it's neither of those, then it's an invalid year. And if it's not a number, then it's an invalid year. Okay, great. That's for Mazdas. What about Fords? Okay, well, okay. Copy all this. I'm going to go and paste this in as another entry here. Change this from Mazda to Ford. And change this from 98 now. We're going to say Fords, we're not going to take anything older than 2001, which is just going to be converted to 1. And then for 1998, we're not going to take anything 2001. Okay? So it has to be 2002 or greater if it's a Ford. Okay? And that works good. What about Toyotas? Okay, well, let's do Toyota here. Okay, let's take this Toyota. Oops. Well, we goofed that up, didn't we? Paste that back in. Let's try this again. So Toyota and Toyotas. We're willing to take 2006 models. So we'll do 6 and 2006. So everything 2007 or greater. Okay? All right, great. What about a Fiat? Okay, a Fiat. Really? Come on, man. This is getting ridiculous, right? We're having to copy and paste all this code. And we're just copying it over and over again. And another problem is that we've got all these fixed values in here. And what if they change over time? Maybe every year we want to change the numbers. So we're not, maybe next year it's going to be 99. And the year after that it'll be 2000 and so on and so forth. So every time that we'd have to go in and fix this up, we'd have to go in and change all our code. We'd have to find where that particular make is. We'd have to go and find the value and change it. And this is very static code. It's very brittle. It's easy to break. And it's very difficult to find exactly where you're looking for. Because what if I wanted to find the Fiat? Well, is it in here? Nope, I don't even see a Fiat in here. So now I got to go in and add it. There's some logic that you have to kind of follow through and look through. If I need to change the Mazda year, I have to look through the code to find, oh, there it is. That's where I changed the year. And the same thing with all these other ones. So it's very brittle. It's easy for us to do something wrong, and it's very coupled. It's very static. There's no dynamic capabilities to this. And it's really violating something called the open-closed principle. And the open-closed principle is part of the solid principles, which are a set of 5 principles you should be trying to build your code towards doing. And the open-closed principle is stating that your code should be open for extension, but closed for change. Now, that probably sounds a little duplicitous. It probably sounds a little bit like an oxymoron. How can I have something that is both extensible but doesn't change? Well, it just simply means that when you code these things up, you should be thinking about how they can be made to be more extensible in the future without having to come back in here and change something. Okay? How can I maybe make this so that it's a little bit more pliable to more scenarios than just this particular one? And anytime that you're programming in static values like this, that's a pretty good indication that you're violating that principle. So what I'm going to do is I'm going to comment all of this out first and foremost. So we'll just go ahead and comment this out. I'm going to leave it in there for posterity. We might come back to it and kind of revisit some of what's in here and do a comparison. But I'm just going to comment that out. I'm going to save what we've got here. And I'm also going to hit this little pending button up here. And this is for Rubber Duck. And our Rubber Duck interface gives us a nice little Explorer window. So I'm going to go up to Rubber Duck, Navigate, Code Explorer. And you'll see that it pops up over here on the right for me. It might pop up as a separate window for you. And if you don't have Rubber Duck, don't worry. You don't have to have Rubber Duck. It's just a really nice way to go about doing things. Now, I've got this in here, and I'd like to add some classes to this application. But before I even begin doing that, I'm going to use this Code Explorer to my advantage. Notice that there's this folder called Interfaces Demo. Well, this Code Explorer allows us to actually folder our class modules, okay, our classes and our modules. We can start to organize them into folders and subfolders. And the way you do that in Rubber Duck is I'm going to put a little comment up here of @folder, and in parentheses, I'm going to pass in a string that is going to be the name of the folder. And I'm going to call this cars. I'm going to name this folder cars. Okay? I'm going to save that, debug, compile, hit the refresh here, and now you'll see Interfaces Demo changes to cars. And now my form module is inside of this cars folder. And one of the other things that I like to do is I like to have the organization of my folders such that the top level folders are the features of the application. So cars would be kind of a feature. It's a big idea, a feature of my application that manages cars. And I'm going to stick my car entry form inside of my cars feature folder. Okay? So just kind of keep that in mind as we're going through here and we're adding new classes and stuff to our application. Now, I've eliminated all this code that does all of the validation for me. And I'm going to replace it with something else. But what is that something else going to be? It's going to be a class. And we need to think about, from the perspective of the click event on the submit button, what would we want this submit click event to do? What would we want it to call? Well, we want it to call that class, and more specifically on that class, if it's going to be doing the validation, it would make sense that let's call this class validate car, and the function that might be on that validate car class would be is car valid. Okay, so it's going to be calling this is car valid function, and based upon that we can wrap this up in an if statement, and inf and if. Now I haven't even created this validate car class yet, and I haven't created an is car valid function, but we can kind of figure out how we want this to work. we can say that if the isCarValid function returns back a true, then we want to go ahead and say me.lbl message caption equals valid submission. Okay? But if it returns not valid, then we want to go ahead and do what? Well, we want to set the LBL message caption to the reason, right? The reason that it failed that validation. The car is too old, or invalid year, or something like that. Maybe it's not a car that we accept. So I don't really know what that is from at this point. I don't know what that message is going to be, but I could leave it up to the validate car class to tell me. And I'm going to make that actually a property on the validate car class. And I'm going to call it failure reason. Okay? So on my validate car class, I expect there to be two members on it. An isCarValid function that returns a Boolean true or false as to whether or not the car is valid. And also, it's going to have a property on it called failure reason that if it fails that validation, it'll tell me why. Now, something that this validate car probably needs in order for it to check whether or not the car is valid is it probably needs to know what the car is, right? It needs to know the entry that we gave for our make and our year in the text boxes. Now, I could probably pass that in directly. I could do me.txt make and me.txt year, but I really that's not really the object-oriented way. That's not storing our values into something that makes sense as its own separate entity. So what I'm going to do is I'm going to create a class called car, and I'm going to pass that in to my isCarValid function. So let's go ahead and do that. Let's create that car class. I'm going to say, I'm not even going to dim it yet. Let's just go ahead and create that class. So I'm going to do cars add class module. And we're going to do, well, what kind of things do we need on this car class? Well, actually, before I even start that, I'm going to go up here and I'm going to add it to the folder. So before I forget, folder is going to be cars. Because again, it's a car class. It probably makes sense to put the car class under our cars folder. Now, what are some of the properties that we want on this? Well, basically, we just need the make and the year on our car class. So let's do that. We'll add a public property, and this is going to be a let make, and this is going to be the value as string, and we also need to do a get. So public property get make, and that's going to return a string. All right, now we need to create a backing variable here, so I'm going to do a private. I'm going to call this p_make as string. And now we're just going to set p_make equal to whatever the value is that's passed into the let. And make, the getter, is going to return the value from p_make. Okay? Now we need to do the same thing for the year, right? So this year instead of the make. So I'm just going to copy this. I'm going to say change this make to year, p year, make the getter year, and this needs to be also year and p year. Now let's go ahead and add private p year as string. Now you might be wondering, why am I doing the year as a string instead of a number? Well, I could do that as an integer instead of a string, but I might run into a problem when the submit button is clicked if it's not a number and I try to assign the value of that year, which is not a number, to a integer year. I'm going to run into an error, and it's not going to be handled by the code. I could add some error handling to the code to kind of check that kind of thing. But the whole point is I don't want my validation to be happening here inside of my click event. I don't want the validating to be going on in here. I want to leave that for this isCarValid function. So I'm going to go ahead and continue to leave that year value on my car as a string, because I can put anything in there for my car year, right? I can put anything in there as a string for my year value, and then I can evaluate that later in my validate car isCarValid function to determine whether or not the year is valid, right? So I'm going to leave that validation to this isCarValid function and not try to do it right here inside of my submit. So that's why I'm going to leave the year as string for right now. Let's go ahead and save this class, and I'm just going to call it car. I could have probably called it vehicle. That would have been fine. Whatever is your preference. But I think that's going to do it for now. So I need to dim an instance of this car as new car. And I'm going to set the values on my new car equal to me.txt make and new car, oops, scratch that. New car make is equal to the text box make, and the year is equal to me.txt year. Okay. Now, instead of submitting car, I want to submit new car. So we'll pass new car into this isCarValid function. And again, we haven't even written one line of this code yet. We haven't written one line of this validate car or isCarValid. And I just kind of want to give you this perspective of a good way to think about how you're designing and developing your code is to think first in terms of the consumer of your class. I haven't written my validate car class yet, nor this isCarValid function, because I want to try to think about how I'm going to use it first. Then, based upon how I'm implementing that class, I can now better understand what I need on the class. Okay? And that's a different direction. That's the direction you should be thinking. Think about the perspective of the user, perspective of the consumer of your objects, the consumer of your classes. That's what you want to try to get out of the way first so that you can better understand how you're going to use those classes. Now, there will be a refactoring phase because you'll find out that there might be something else you want to add that you didn't think of. But in general, we're starting to get a clearer picture of what we want in our validate class, our validate car class. So I've got a pretty good idea here, and I don't think that there's much else I want to do at this point to figure out what this validate car class should do. So let's go ahead and build it. Let's go ahead and do a new class module. So insert class module. And this is going to be a validate car class. So I'm going to put it under the folder. It's going to be under cars, but this time I'm going to do a subfolder, and I'm going to use the dot, which if you're familiar with .NET, it looks a lot like a namespace. Okay, this cars dot, and I'm going to say validation. Cars.validation is the name of the folder. Okay, and I'm going to go ahead and call this validate car. And we can see now that this new class, this validate car class, creates a subfolder under the cars folder called validation. And that is now where we can find our validate car. And I just want to double check, is that what I called it up here, validate car? It sure is. Okay, so I just want to make sure I'm naming things appropriately. Now, I should go back here and take a look. And remember, this isCarValid function should return a type of Boolean, right? That's why it's inside of this if statement. And it should take as a parameter a type of car. So let's go ahead and create our isCarValid function, public function called isCarValid. It takes a type of car, and it returns a Boolean. Okay? So that signature was basically already written out for me. I already knew what I'd need in it just because of how I was planning on using it right here. Now the other thing, the other part of what we're doing here is on the validate car class, we need a failure reason in case there is a problem with the validation of the car. So I'm going to go to my validate car and I'm going to add a public property. And I just kind of want to point out here, the only way that we're actually consuming this failure reason is to get the value from that failure reason property. We're not setting the value of failure reason. We're only getting the value. So that means we only need the get accessor for the failure reason property. Okay? And it's going to return back as a string. So, now this failure reason property, I always like to move my properties up in my class so that they come first. And this failure reason is going to need to return some sort of value. So we're going to say failure reason is going to return what? Well, I don't really know yet because that failure reason is going to be set based upon what this isCarValid function does. So instead, I'm going to reserve that to a private variable that I'm going to set down here in my isCarValid function. And let's go ahead and create that private backing variable. Okay. And now our function, this isCarValid function, what is it going to do? Well, I could take all this code here, right? All this stuff that checks the Mazda, the Ford, the Toyota. I could move it into this isCarValid function, and I just need to kind of, adjust it to match this new environment, this new class. Change the valid submission. Instead of returning back to the caption, it instead puts it for the failure reason. And the Mazda check, the check to see the text of the make, would be, instead of checking the text box, it would check the car make. But really, that's not really going to solve our problem. We're still going to have that coupled code. We're still going to be hard coding these values of Mazda and the years. So that's not really the solution that we want. Instead, let's think more in terms of an object. What can we do? Let's take, for example, this checking to see if it's a Mazda. Well, that's really a validation rule. Is the make a Mazda? Right? That's a validation rule. So what we want to do is to make things more modular. Let's say that we have these things called rules, these validation rules. And these validation rules, they're going to need some properties on them too. They're going to need, just like how we had when we called from our form, we were calling the isCarValid to see whether or not it was a true or false. We kind of have the same thing here for what we want to do for our validation rule. We want to see, is valid? Is the validation rule valid? And then if it's not valid, then we want to see the failure reason. Right? Kind of very similar things here between what we did with our validate car class and what we want to do with this validation rule class. But if you think about this a little bit more, if we were not just going to be dealing with the Mazda rule, not just this one, but also is numeric, that's a rule. If the length is equal to 2, that's a rule. If the year is greater than 98, that's a rule. So we have a whole lot of rules that we want to go through here, more than one. So I don't want to create a class that's just going to be the validation rule that only checks one of these things. Instead, I have a whole bunch of different things that I want to be checking. But each one of those rules could return an isValid property and a failure reason property. Right? Each one of those rules would tell me if it's valid, and if it's not, why it failed. So I have the makings here of an interface, because each one of those rules, although the logic behind them, right, the logic that we have here is going to be different for each one of them, the ending result and the properties of that validation rule are really the same. they all need to have an isValid value and a failure reason value. So what I'm going to do then is I'm going to create an interface that just implements these two properties. So I'm going to go to my class modules. I'm going to add another class module, and I'm going to put this in a folder, and I'm going to call this validation. Okay? It's separate from my cars because if you think about it, this process, this check to see if the validation rule is valid and the failure reason, it's not strictly for just cars. I could be doing a validation rule on anything, anywhere else in my code. I might be able to reuse this is valid and this failure reason. So I'm going to move that into my validation folder that's going to create its own folder for validating different items in my code. Now again, I only need two properties, the isValid property, so I'm going to copy that and we'll add that as a public property. And again, it's only a get, right? It's this isValid property. I'm only calling it to see if it's valid. And I'm only going to ask the same thing of the failure reason. So really these two properties, I'm not setting them in the caller, I'm only getting them. So public property get is valid, and it should return a Boolean. Now, since this is an interface that I'm defining, I don't have any logic behind it just yet. I'm just stating what the members of it are. Okay, and that's it. I do need to give it a name, and a typical naming convention for interfaces is to start with a capital I, and I'm going to say I validation rule. And now you can see once I save that, the rubber duck auto refreshed, and it found that I put that validation folder up there, and it put my I validation rule inside of the validation container. So I've defined an interface that just says a rule. In order for a rule to be an I validation rule, it must have an isValid property that returns a Boolean, and it must have a failure reason that returns a string. And that's it. That's all I need for my interface. Okay? Now let's go back to my validate car function. Now that I have these two properties on it, I can kind of figure out how I'm going to use them, right? So if validation rule is valid, then I'm going to say is car valid equals true. Else I'm going to set the p underscore failure reason, that private variable, equal to the failure reason given back from the validation rule, right? So it's very, very similar to what we were doing here back with our form, where we were doing this is car valid, and then we were setting the caption of the failure reason to whatever came back from the validate car class. It's very similar in logic here, except now instead of an actual concrete class, it's actually an interface class. Okay? So you can think of this as an interface of I validation rule. Now, this is going to change a little bit because it really shouldn't, we're not going to actually say I validation rule. I just kind of wanted to put the I in front of it there to emphasize that this is an interface that is supplying the value for is valid. And this is an interface that is supplying the failure reason. Okay? Now, with that in place, and now that we know that we want to supply or we want to check over a multitude of different failure reasons, right? A different set of validation rules. And we have all these different validation rules in here. We need to supply to this validate car that list of validation rules. but we haven't even created any of those rules yet. So maybe we should do that first. Let's create a validation rule that implements that I validation rule. So we'll do insert class module, and I'm just going to go up here and add it to a folder. And that's going to be the cars.validation, because this is going to be a rule specifically for car validating. Now this rule is going to implement I validation rule. And once we have that, I'm going to save this. And I don't really have a name for this. I'm just going to call it foo for right now. I'll go back and rename it later once I have a better idea what it's going to do. But now I can go ahead and right-click on Implements. I'm going to go to Rubber Duck, and it makes this really easy. I go to Refactor, Implement Interface. And you can see it just automatically generates the two get private properties for my isValid and my failure reason on that I validation rule interface. Okay? So what's the first rule that we want to check? Well, let's say, first of all, that maybe we want to find out whether or not it's even a car that we're willing to accept, right? Because I've only got Mazdas, Fords, and Toyotas that I'm willing to take. So maybe our foo class is going to be allowed make or allowed makes validation rule. Okay, and I like to append validation rule to the end of any classes that would be a validation rule, because it helps me identify that this is a validation rule class. So allowed makes validation rule. So now that we have that, we know what it's going to be named. Let's think about how we want to implement this. How are we going to implement the isValid property? Well, the first thing that we probably need on this is we kind of need to know what the car is, right? We need to know what that car is in order to validate it. So where am I going to get the car value into this validation rule? Well, what I like to do is, since this is a property, it's not a function, and I can't pass a parameter to it, and same thing for this one, I'm going to create my own little function that is going to be public. And actually, it's going to be a subroutine, excuse me. It's not going to be a function. It's going to be a sub. And I'm going to call it init. And this is just kind of a practice that I have come to do for VBA, because trust me, every VBA coder out there who does anything with classes really, really wishes that there was a constructor for VBA classes that allowed you to pass parameters to it. But unfortunately in VBA, there are no class constructors that allow to pass parameters. But you can create a function, or a subroutine in this case, that you want to do all of your setup and your initialization details on it. So what I'm going to do here is I'm going to say that when the caller calls this allowed makes validation rule, they need to call the init function, and they need to pass in a car as part of that init subroutine. Okay, and then I'm going to set that car to a private variable called pcar, and we'll just declare that private variable here. Okay, so I've done that. We're going to force the user to pass in a car. Now, we also need to know whether or not it's going to be a Mazda, for example. So maybe we'll tackle something else a little bit later. You'll see what I'm going to get to here in just a moment. But for right now, we want to fix this isValid rule to check and see whether or not a car was even passed in. Because if a car wasn't even passed in to this init function, then this isValid won't even work. We need some sort of car to look against. So I'm going to do if isNull p underscore car, then. Now I could make this a failure, right? So I could return the I validation isValid, could return false. and then I could set the failure reason to return what the reason was, and I probably actually should also say that this failure reason is going to return some sort of failure reason property, or failure reason value from a private variable. So let's do that. P underscore failure reason. So private P underscore failure reason as string. Okay. So now I could set that P underscore failure reason equal to no car set or something like that, but that's going to trickle up to the customer in the end. And really, the problem is not with what the customer did, but with what the programmer did in not calling the init function and passing in a car. So rather than do this validation message, I'm going to go ahead and raise an error. Okay? Now, that raise of an error, I'm just going to do VB object error. I'm going to leave the source open. I could specify the source here and say, allowed makes validation rule. Maybe that's better to do. Just go ahead and specify the source. And then the description would be failed to initialize. Okay, so that works pretty good. I think that'll work just fine. And that way it's more specifically an error that gets raised to the programmer. Now the user might get that too if the programmer didn't do it right, but hopefully this is caught during the development process. And in fact, since this is all it's going to do, I'm just going to move this all to one line here and get rid of the end if. Okay, so we want to check to see if it is a Mazda. So if the P underscore car make equals Mazda. But understand that isn't this basically what I told you not to do? Right? I'm putting a static value in here of Mazda. So maybe instead of doing this Mazda like this, we want to pass in perhaps some sort of list of makes that we're willing to accept. So let's do this. I'm going to say accepted makes as collection. Okay, so I'm going to pass in a collection of accepted makes as part of the initialize, because I don't know where else I could possibly put this in, right? I mean, this collection that I need to pass in of acceptable makes, I probably need to pass it in as part of the init since there's nowhere else to do that. So I'm going to do that. Now what I can do is I can check and see on a for each loop, and actually in order for me to do a for each loop, I'm going to need to also create some sort of private variable, P underscore accepted makes as collection. I'm going to need to do a for each loop on this accepted makes. So I'm going to set P underscore accepted makes is going to equal accepted makes. And now we can do a for each loop. And for each accepted make in our P underscore accepted makes, we're going to do that if check, right? We're going to check and see if it's a valid make. Now, in order for this to work, I need to create an accepted make variable here, and it needs to be a type of variant. And we're going to check to see if the car make equals that accepted make. Then once it does, we're going to go ahead and set the iValidation rule is valid property to true. And we can go ahead and exit out of the property, right? Because we're done. Once we know that we have found a make in our collection that it matches, then we can go ahead and exit out. Now the other thing I should probably do is I've checked to see if the car is null to raise an error. I should probably do the same thing here for my accepted makes collection. Okay, so I'm going to do this. I'm going to say if P accepted makes is null, then also raise the error. And I could do if, actually, just make this all one line. There, and get rid of this second one here. Okay, so that way we have one line that basically does all of that. So we have this looping going on over the accepted makes. So when the user of this class, this allowed makes validation rule, when they create this rule, they need to pass in the car type as well as the different kinds of makes that we're willing to accept. And then if it matches any one of those, then it's going to cause it to be true. We should probably go ahead and say if none of those work out and we haven't exited the property, then we need to set I validation rule is valid equal to false. Right? That way, if none of them match, then we're going to make it false. And then if it does come to be false, then we need to give some sort of failure reason. So I'm going to say P failure reason is equal to not an accepted make. Okay, nothing real special there. Maybe you could come up with better wording than I will, but I'm going to leave it at that. Okay, so not an accepted make, and it looks like we're good on this validation rule is valid property, and our failure reason is being set if it is false. The way that we do it is this iterative loop here, this for each loop on every one of our accepted makes that gets passed in as part of our init function. If the user forgets to put, or if the developer forgets to pass in a car and a collection, and it turns out that it's null, then we're going to raise an error to that developer to let them know that they need to pass that in. Okay? I think we're pretty good on this validation rule. And you can see that all of the logic is in here, and it's fairly complex, right? We're checking each one of the accepted makes. We have to pass in an accepted makes as a collection for the init function. And even though we have all this complex logic, when we do eventually pass it into this validate car, this if statement to see if it is valid, it doesn't really matter to this is car valid function how that is being calculated. All it cares about is that it is valid. It returns true or false. If it returns false, then give me the failure reason. Since this is not the only validation rule that we're going to be making, because again, we have a lot of different rules that we want in here, right? More than just whether or not it's a valid make. We also need to check to see if the year is numeric, well, maybe that's the next one that we want to do. Is it numeric? Let's do that. So I'm going to add the next class module here. And this one I'm going to put under folder. Do folder. Oops, I forgot the ampersand. Ampersand folder. There we go. And this is going to go under cars.validation. All right, and we're going to check and see. We want to implement implements I validation rule. Okay, we'll save this, and this is going to check to see if the year is a number. So we're going to say year is numeric validation rule. Okay, and we can see that it gets placed underneath our validation subfolder. There is year is numeric validation rule. Now we need to implement this validation rule, so go to rubber duck, refactor, implement interface. There we go. And I'm going to take some of the stuff that I've got. Well, we'll talk about that a little bit later. We might need to bring in some of this logic that we've already got into this. The first thing, of course, that we need is to make sure that we have a car, which again, we needed to create a public sub called init, and that init needs to take a type of new of car, right? And then we're setting p underscore car equal to, and actually this needs to be set p underscore car equal to car. And then we're going to make a private p car variable as car. And I do need to check to make sure whether or not car is set. So I'm just going to go here and I'm going to say if is null. Just copy all of this. And I'm not passing in an accepted makes, so I can drop that part. All we're really checking is to see whether or not the car is null. Then after we're sure that we have a car here, we're going to actually do our validation. So we're going to say if p underscore car dot year, we're going to say is numeric, right? And then, okay, so if it is numeric, then that passes, right? So we're going to say I validation rule is valid equals true. Otherwise, and we'll just go ahead and exit out of the property. Otherwise, the is validation rule is valid is going to equal false. Save that. And we do also need to set the failure reason property, right? So this thing here needs some sort of result back. I'm going to copy this. I'm going to say it is set to whatever p underscore failure reason is. And so private p underscore failure reason as string. And we're going to set p underscore failure reason equal to invalid, or no, we'll say year is not a number. Okay. So that's another one of our validation rules that's implemented. Now, how do we get just these two rules? I haven't really done the actual implementation of these rules yet into our isCarValid function. How do we get these validation rules into this isCarValid function? Keeping in mind that we want to do more than one, and we really just need to do this logic on each one of them, right? Because each one of them offers up this isCar or this isValid property as well as this failure reason property. So we know that this is going to work for each one of them. And I think that probably should be a clue here. Just like how we did with the allowed makes, where we did a for each loop on these makes to find it, we can do a for each loop on this isCarValid function. So that's what we're going to do. We're going to do a for each. And for each validation rule in, I'm going to say validation rules, which we haven't created this yet. Tab that over. Next validation rule. Let's go ahead and define a validation rule. So we'll do a dim validation rule as a variant because it is part of a for each loop here. And so we've got a for each validation rule in our validation rules. Where are we going to get this validation rules at? Well, I could do another public sub init, another public sub there called init that takes the validation rules. But actually, I'm just going to go ahead and do it here inside this isCarValid function. And these validation rules can just be a collection of validation rules, right? That's all it needs to be. So I'm just going to do that. I'm going to say validation rules as collection. Okay, so we're going to pass in the car, and on each one of the cars, we're going to need to, or I'm sorry, in each one of the validation rules, we're going to need to probably pass in that car somehow, because each one of these validation rules does require the init car, right? So how are we going to make that happen? Well, it's not really up to this isCarValid to pass in the car, because the validation rules should already be set and initialized when they go into this collection. So really, I don't even need this isCar anymore, okay, or this new car. I don't need it, because the validation rules themselves, when they get initialized, they're already going to have the car inside of them. So that eliminates that isCarValid. All I need to do is pass in this set of validation rules as a collection and iterate over them to see if any one of them had a problem. Now, I probably do need to touch up a little bit about how this for each loop works now, because if each one of these rules turns out to be true, we don't want to keep resetting isCarValid to be true. We can instead leave that up here. We can just default initialize that to true. And the only thing that we really care about is if there was some instance where it was not true. So we're going to say if not is valid, then that's when we care, and that's when we're going to say the isCarValid function should return false. And then we also set that failure reason, right? So that's really the only thing that we need to do inside of this for each loop. Otherwise, it's going to be true. So the car is always going to be true unless one of those validation rules causes it to be false. Now, you could work it a little bit differently. If you wanted to reverse that direction, you could say, it's going to be automatically false unless it matches one of these validation rules. That's perfectly acceptable as well. It just really kind of depends upon how you want to do it. Now, with that in place, and we've got a couple of rules built, this year is numeric and the allowed makes validation rule. Let's save this. Let's debug it. Make sure, did I do anything that I might need to fix here? Yep. Variable not defined. If validate car. Oh yeah, look at that. I did not even instantiate an instance of validate car. So let's go ahead and do that. So dim validate car as new validate car. All right. Save that. Debug. Compile. Variable not defined. Oh, yep. It's not car. It's new car. Gotta always check these little bugs. Where did I fat finger? I did a lot of things without testing here, so that's not too bad. Now, let's go back to our entry form here. I'm going to go ahead and get rid of all this extra stuff here, all this commented out code. And now what I need to do is I need to pass into this isCarValid. Instead of passing in the car, I need to pass in a set of rules, right? These validation rules as a collection. Let's go back. There it is. The validation rules as a collection. And it's expecting that each one of those validation rules is going to be a type of validation rule. All right? So what we're going to do is instead of passing in the new car, we're going to pass in a collection. So let's create that collection. I'm going to say dim. This is going to be validation rules as new collection. All right. Now inside of here, I could go ahead and create each one of my rules that I want to pass in. So I need to create a new, so dim allowed makes validation. Oops, let's just call this allowed makes rule as new allowed makes validation rule. And you can see that this could probably get a bit long and laborious. This arranging of the rules is inside of our submit button. And that means that it's really kind of difficult to find. It's difficult to identify where all these rules are getting created. So a better solution to this would be, instead of defining our rules inside of the submit click event, let's create our own little private function that's going to return a collection of validation rules. So I'm going to do private function. I'm going to call this car validation rules, and it's going to return as a collection. Okay. Now, since I'm not going to be dimming a validation rules anymore and passing that into this isCarValid function, I'm just going to pass in this car validation rules function itself, and the results of this function are going to be passed into the isCarValid function. So I can go ahead and get rid of this validation rules collection there, and I'm just going to pass in the results of this function of the car validation rules. And now I can go ahead and define each one of my rules. So I'm going to say dim rule 1 as allowed makes validation rule. And actually, I'm going to make this a new validation rule so it instantiates right away. And let's do rule 2 as new. Year is numeric validation rule. And now I need to do the init on each one of these. So I'm going to do rule 1 init. And the new car. I need to pass in that car, don't I? So I'm going to make that a parameter. And I'm going to just pass in new car to my car validation rules. All right. So now my init can take that new car as the first parameter, and the accepted makes as a collection. Well, I'm going to go ahead and define that here. I could possibly define that elsewhere, perhaps in another function or another class or something like that. But I'm just going to go ahead and, for the sake of simplicity here, I'm going to define accepted makes as collection. Actually, this is going to be a new collection. And I'm going to add some makes here. So I'm going to do accepted makes add, say, Mazda. Accepted makes add Ford. And accepted makes add Toyota. Obviously, I could add more, but you can see that what's nice about this is that I'm kind of defining all of this inside of one function, right? I know exactly where I need to go to, this car validation rules function. And this is where I go to set all of my rules. I'm setting them up. I'm making my accepted makes collection, and now I'm going to pass that in as to my first rule. And then I'm going to do rule 2 init, new car. And it doesn't take any second parameter, so it's fine just like that. Now, this car validation rules needs to return a collection, right, of these rules. So I'm just going to go ahead and define a new collection, dim car validation rules as collection. And it needs to be a new collection so that I can add stuff to it right away. And now I'm just going to add car validation rules dot add rule 1 and car validation rules add rule 2. And as I get more rules made up, as I get more classes of rules, I just need to add them to this car validation rules function and add that rule to the car validation rules collection, which will return back into this validate car class with the isCarValid function on it, and we're good to go, right? So all I have to do is the extensibility is I just have to make my changes and my modifications of my rules inside of this car validation rules function. This should probably, I want to do this as a capital C. And I don't want to do that. I want to dim Boy, it doesn't like that. Let me fix this up. Car validation rules equals, I'm going to say new car validation rules. I'm going to rename this so that I don't get it confused. New car validation rules. Okay, that way there's no miscommunication there. So now I think I'm good to go. I've got my rules set up. I probably have something in here I'm missing. I usually do. I mean, there's a lot of code that I put in here, so who knows what I've gotten wrong. Let's go ahead and inspect it and do all that good stuff. All right, let's debug, compile. Yep, argument not optional. Oh, yep, I know why. Set. I forgot to use the set keyword here. All right, save, debug, compile. Oh, look at that. It took everything. Okay. Now, I'm not sure that everything works exactly how we have planned. It should conceptually, but I might have missed a few things. So let's go ahead and give it a try. I'm going to go to my form. And I'm going to say for the make, I'm going to do a Chevy. Okay, something that I know is not one of the models that or one of the makes that we've said we'd take. I'm going to say 1998. I'm going to submit that. Object variable or with block variable not set. So this is why we do these things. Why is it not that way? So rule one new. Why is it not liking this? Oh, because it's new car validation rules. There we go. Since I renamed that variable up here, I needed to add it there. Okay, so let's save that. Let's keep running. Object does not support this property or method. Where are we at now? Okay, validate car. Maybe it's something internally, so let's step through the code here. All right. Init new car. So we're setting up our rules. We're returning our rules. Those rules are being passed into the isCarValid function. Now for each one of them, object doesn't support this property or method. So this is actually in the isCarValid function that we're getting the problem. So let's just step back to that point again. All right. So for each validation rule, in validation rules, each validation rule should be a type of validation rule. Now it doesn't really like that, does it? Not validation rule. The not validation is a valid property. Object doesn't support this property or method. I bet that's because we're not doing anything in a type-safe manner. Because this shouldn't be a variant. This should be as a type of, oops. This should be a type of as I validation rule, right? That's what it should be, not a variant. Let's see if that fixes it. So we'll debug, compile. Okay, it still likes that, so let's try this. Submit. Not an accepted make. Ooh, good. How about Mazda? 1998. Valid submission. Well, that's probably because I haven't really added anything else in there. Let's say the year is AVSFAS. Year is not a number. Look at that. How fantastic is that? Say 98. We'll do Chevy again, and we get not an accepted make. Mazda 98, valid submission. So you can see we're iterating through these rules that are dynamically modifiable. We can make new rules, right? Let's try one more here. Let's try something like, if it's a Mazda, then we want something newer than 1998. So let's do that. We'll add one more class, insert class module, and this is going to be implement I validation rule, and we want to go ahead and implement that. So we'll do refactor. Oh, it's not there yet. I gotta hit that button first. Now I can do it. Refactor implement interface. All right. So I need a car. So I'm gonna need to build my public sub init, and it's gonna need the new car as car. All right. And we're going to have a private variable, private p underscore car as car. And we're going to set p underscore car equal to the new car that's being passed in. Now we need to do that raising, and I'm just going to copy again. Actually, not from this one. Let's do it from the years numeric. So we'll do copy all of that. We'll go back to our class, and we're going to say check to make sure that car has been set. Otherwise, we've got a problem. All right. And now we're going to check to see if, since we know it's a Mazda, or maybe we need to know whether or not it's a Mazda. So if we specify if p underscore car make has to be a Mazda, then we've already started to violate that principle again, right? So that's not what we want to do. Instead, we want to allow the user to pass in the acceptable make, right? And or the model or the make of the vehicle and the number that we're going to compare it to. So we're going to say so accepted, or let's say the car make. Let's do this as lowercase, car make as string, and car year as integer. Okay? And maybe we could come up with a better name than that because we would think that that's already on there. But that's fine for now. We know what it means. Maybe we should do something like, well, we'll revisit that. We might have to revisit that a little bit later. So we're going to do car make. If car make equals make, then we're going to check to see if car year is greater than, or actually we're going to see if the p underscore car year is greater than the car year, the one that gets passed in. Now, so if it's greater than, so if the year of the car is greater than the car year, or let's say I'm going to say greater than car year, and that's fine as car make for right now. So we'll say greater than car year. So we're going to say p underscore car. So we're checking to see if the year of the car is greater than this value that we're going to enter. And actually, I just realized that should probably be a private variable. So p underscore greater than car year is equal to, yes. I really wish they'd get rid of that error. I know I've missed it. All right, we're going to create that private variable as integer. Okay. Add a little separation there just to make it easier to read. And now it's going to be the private variable that we're checking against, not the one passed in. Okay, there we go. Okay, so if it is greater than that year, then we're going to say the is valid is true. So we're going to say validation rule is valid is equal to true. We're going to exit the property. If it's not, so if it does match the make, then we want, but we don't match the year, then here we're going to do an else statement that the I validation is false. Okay. And then we also want to set the failure reason, which it looks like we need to add that private property here, or the private variable. Let's do private p underscore failure reason as string. And now we'll just do this, copy that. copy that, and we're going to say that it is equal to that private failure reason. I'm going to copy this again, and I'm going to set it equal to this car is too old. Or just the car is too old. We'll do that. Okay. Now the class, what do we want to call this? This is going to be specifically checking to see not any particular type of make or anything like that. Really what we're comparing is to see whether or not the car year is too old. Validation rule. Okay? And then we could do one, for if the car needs to be less than a particular year, or it needs to be exactly equal to 1 year. We could just keep creating these rules that, are a little different and tweak that a little bit. So that's what we can do there. Now, I like what we've got here so far. Now, if the car make does not match, then what do we want to do? So if the car make does not match this rule, then it really does pass, right? So I'm going to say is valid true is going to be the default here. And if that's the case, then I guess I really don't need, if it's not, then I don't need any of this, right? So if the car year is not greater than the greater than year car, or greater than car year, then it's going to go ahead and give that. So if it's not greater than the year, otherwise it's always going to return true. So if it's not the right car make, and if it is greater than, if the car year is greater than the car year, then it's going to return true. So I think that logic flows just fine. We'll try debugging and compiling. Variable not defined. Where did I miss that? If car make. Oh, again, there is my car make. I should probably make that a private variable. P car make as string. Oops. And it's going to be equal to car make private P underscore car make equals or as string. And I should probably be also checking to see that these values contain something, but I'm fine with this for right now. I think just leaving that is null for checking to see whether or not the car is there. I'm good with that. You guys get the gist of this, I think. I could be more complete about that, but whatever. As long as you guys get it. Oh, and this should be P underscore car make. All right. Save, debug, compile. We're good to go. Let's test this baby out. So, oh, I need to add the rule, don't I? So now that I've added the rule, I need to add it to our car validation rules, don't I? So we're going to add another rule. We're going to say dim rule 3 as new. Car year is too old validation rule. And let's see. We're going to say rule 3.init new car. The car make we'll say is Mazda. And the greater than car year should be, let's just say 1998. Okay. And we need to add this new rule to the new car validation rules, which then gets set and returned for our function. And that's just going to be passed right into our isCarValid. So that's all I need to do in order to set up this new rule. All right. So let's go ahead and check this out. Let's try Mazda. Let's do 1979. And valid submission. That shouldn't be. Let's try something else. 1952. Did I goof something up? I might have. Let's check it. Let's check and see what we get here. I'll stop it right there. I probably did something in my logic that is flawed. Okay, so my rules are set. is valid. Okay, is car. So that's my is numeric check, which it turns out it is true. Is the year, okay, so here we go. The year is 2001, the greater than, looks like we forgot to convert the string to an integer. All right, so that's what we need to do. Looks like we need to convert the car year to an integer, so we'll do cint. That's a good catch. We already know it's numeric because we're passing that other validation rule, so we're good here. All right, try it one more time. Submit. I can get rid of that breakpoint here and just continue. And valid submission. Let's try one that should fail. 1979. That still says a valid submission. Why are we getting that? Submit. So we've added all our rules together. Now we're going through each one of them. Getting the year. Is the year valid? Is it numeric? Yes, it is. Okay, so now we're actually going into the one that's failing here. We're saying the car year is 1979. If it's not greater, is that right? So is valid. Oh, we did not exit out of the property after we set our failure reason. So that's something we need to do. Exit property. All right. Try it again. Let's just run it through. There we go. Car is too old. Okay, so we just had some debugging stuff we had to get rid of. But you can see how this makes our code much more dynamic. We can just add more rules to this car validation rules, and we could really put this into its own class that does the validation rule component. And what would be really great is if we could do some dependency injection into this, so that every time that the application was started up, maybe we looked at a database for all of the values that should be loaded up into these rules. And we could just do an iteration of that and create a new rule based upon maybe the name that we've given it. So there's a lot of really cool things that we could continue to do, and I hope you guys can see how this makes it so much easier and nicer to just keep adding your rules in a very simple manner. You just create a new rule here for a class module, you add it, and fill in the values for that rule into your car validation rules, and then that just automatically goes into this logic for the isCarValid function, and that isCarValid function determines whether or not it's proper, and if it's not, then it spits out the failure reason. And all of that, of course, goes back to this for each loop that is iterating over this interface, right? So we're not just going over any old set of rules that, anything that's nondescript. We're using this iValidation rule to show that this validation rule is going to have an isValid property and a failure reason property that we can rely on for this for each loop. We know that those two properties are going to exist because we've defined them here in our interface. And that's what makes interfaces so wonderful. That's why this is such a wonderful tool that makes code like this look so much easier and nicer to manage and deal with down the road. If you need to make a modification to a rule, simple. You just change it. If I don't want the Mazdas to be 1998 anymore, I need them to be 2005. Well, all I have to do is just change it there, and I'm good to go, right? And now my code will work. That if it's too old still, if I do 2007, then it's a valid submission. So I hope you guys can see how this is beneficial. If you guys have any questions, I know there's a lot that we've covered here. It's been a really long video. I hope you guys managed to make it all the way through to see the glorious result that we get in the end. If you do have any of those questions, please feel free to drop me a comment in the comment section below this video, and I'll definitely get to it and answer it for you. Anyway, I hope you guys have a wonderful rest of your day, and thank you so much for watching. Bye-bye.